recording now. Sorry about that. Thanks, Michael. Okay. So like I was saying, there's 20 input output pins available, 14 digital and 6 analog. So, okay, so what condition would you want to use the TX and RX pins? Let's say you're communicating to another Arduino. So like you had an Arduino over here, and you want these to be wired together. You would use the TX and RX pins to communicate. There's different communication protocols. So one of the ones that I'm really familiar with is I2C. And those, they would use the analog pins over here to communicate with these. But the serial pins can also be used to communicate using a different protocol. So the TX and RX pins are by default like the serial communication. So every time you're using your USB to program your Arduino, you're using the TX and RX pins, except they're also wired over here. So if you were to build your own USB header, you would use those pins to plug into the USB. So like if you had a module like this right here, but you wanted to connect it to something else, you would plug into the TX and RX there and plug into that. The Arduino Mega actually has 3 serial port options. So it has, like, I don't know if you can read it right here really well, but it has TX3, RX3, TX2, RX2. And so you can plug in 3 different types of serial devices into it. And I'll explain about the serial a little bit later, but you'll see that it comes in really handy because you can use it to monitor what's the Arduino's doing. So I'll talk about that a little bit in the code. Serial is just the communication protocol. So let's see, an easy way to explain it. It means that if you know like series and parallel, it means that the bits come one after each other. So there's a continuous stream of zeros and ones versus parallel, where it would be like 5 ones that come at once and then 5 different zeros or ones that come afterwards, if that makes sense. Okay, for sure. Sorry if that wasn't a very clear definition, but it just one like flows together, and the next one, parallel, would mean it flows like multiple at a time. Okay, so back to the technical specifications of an Arduino. So Arduino has 5-volt logic signals. So that means that whenever you send a high from an Arduino header, the voltage that it's sending out is 5 volts, or it's a range between, I think, from 4 to 5 volts. It might be a little bit under 4 volts. And then when it sends a low, it's a range between 0 to, I think, a little bit under 1 volt. So that's the logic levels that it's sending out. And so, as you can see, this gets a little bit more technical, might be a little bit beyond the scope of this, but as you can see, there's a range in between where it's indeterminate, and that's what you call like floating, and that's something that we're going to try to avoid in our circuit right here, and I'll talk about that a little bit later. But basically, you don't want to be in that range between 2 to 3 volts, because at that point, the Arduino, it's a digital device, so it doesn't know, like, is it a 0 or is it a 1? So it's like kind of just guessing, and you get a lot of noise in there. Yeah, exactly. So another thing to keep in mind is that the Arduino, it can supply 5-volt signal power, right? Like how we're powering these power rails right here. But the max output current it can provide is 40 milliamps per pin. So let's say you're drawing, this LED draws 40 milliamps. That's as much power as it can provide from that one pin. And the whole device itself, so from all the sum of all the pins, it can only provide 200 milliamps total. So that means that you can have 5 pins drawing 40 milliamps at once before the device just doesn't let you do anything. And so when you're powering servos, motors, that is something to keep in mind, because you want to draw power from its own source. You don't want to have the Arduino providing that power. So you would have your own dedicated power rail that would power the servos. So that's just something to keep in mind. The Arduino also can provide 3.3 volts, like regulated power, and that's also from one of these pins over here. So moving forward. So Arduino is used, Arduino IDE is used to program Arduino. You can use other systems to program it too. So you can use Visual Studio Code with the Platform IO plugin, but it's a little bit finicky. I've used it before, but I personally just like the simple, intuitive UI of Arduino IDE. If you guys want, you can go out and look up some tutorials on using Platform IO for Visual Studio Code or Atom, GitHub Atom. Those are some good text editors. I think Sublime might also have it, but those are good options. If you guys have not already, please go ahead and download the Arduino IDE from the website. I will post the link again in the chat. And it's available for Mac OS. Okay, so like I said before, Arduino is programmed, is based off of C/C++. So the same conventions for the variables apply. You end all the lines with semicolons. The if loops, the for loops, they're all pretty much the same. So if you know any of that, if you have any background in programming, you'll transition over pretty smoothly. There's some key differences in an Arduino IDE, or just Arduino in general, that you should keep in mind. The code is continuously run. So when you put power into your Arduino, it's going to go through a setup code, which you can see right here, which is the first lines 1 through 4. Once it does setup code, it establishes all the variables, all the stuff. Then it goes into the loop, and that loop runs forever, basically until you power it off or until you get into some like interrupts. We won't be going into interrupts because those are a little bit beyond the scope of our class today, but that's just something to keep in mind. So another thing you want to do is this Arduino, the code runs inside this microprocessor, but it doesn't really know like what's connected to what pin or which pins are inputs or outputs. So you have to, before your setup or before your loop for sure, you need to declare if like what pin is connected to what, and if that pin is a input or an output. You can't have a pin be both. You have to decide if it's an input or if it's an output. So moving forward, so this is a sample code. Basically what this code does is that it makes an LED flash on and off, and it just does that with a 1 second delay. And I'll just kind of go through line by line with this, and then afterwards we'll start building our actual circuit right here and then start programming it. Okay, so for this code, like I was mentioning before, you need to declare what pin is connected to what. So we're saying right here that this LED pin is connected to pin 8. So we're declaring the position. And then we go right into the setup. And in the setup, we're declaring the LED pin as an output. So that makes sense, right? The LED, given a signal of 0 or 1, it'll turn, given a voltage of 0 or 5 volts, it'll turn on. And then this is where we start the serial monitor process right here. So like I mentioned before, we'd be plugging into via USB-B to the computer, and we'll be utilizing the RX and TX pins, right? But those pins are actually already connected to this USB hub right here. So what serial does is that it starts a console or a monitor, and you can start outputting stuff to that monitor as the code's running. So this would be like if in JavaScript, it'd be like the console log. I think Python, it's called the console. Java, it's also the console. So this would be the equivalent of that. And so this number right here, 9600, is, sorry, I'm reading the chat right now. Oh, okay. So constant and define are kind of pretty much the same thing. So what constant means is that it's a constant integer, and it's an integer because it's a number. So that means that it is unmutable. You cannot change it once you declare it. And define is also pretty much the same thing. So you're just defining that uh, variable LED with whatever afterwards, right? So you can use define to define um, like libraries and stuff like that too. So there's no real difference besides just syntax. Uh, yeah, actually, I think it goes down into like if you're very it goes down into like the memory and saving like time and memory on the microprocessor. But for our purposes, we're not going that in depth, so it doesn't really matter. But when you're going into like trying to save um, milliseconds or like microseconds off, that might come in handy, or like save space. But for our purposes, it's good enough. So yeah, so what I was saying about the serial is that this number right here, 9600, is the baud rate, and which is the basically the transfer of data, the amount of bits transferred, uh, the bit rate of transfer, and you can change this to whatever number you want. So there's a few specified numbers. I think the next one is like 100,016 or something like that. But by default, Arduino uses 9600. And let's say this comes in handy when you're communicating with other devices. Let's say you have a sensor, right? That sensor has if you check the data sheet, it's going to have a baud rate. And you need to communicate with that sensor at that specified baud rate, or it's going to read gibberish. It's not going to know when like the signal is uh, coming through or not. So just that's just something to keep in mind, that you want to check the data sheet to make sure that your baud rates are compatible between your Arduino and whatever sensor that you're communicating with. But for now, 9600 is fine. Oops. Okay. So now we're going into, so that's the setup, right? So setup runs once. Now we're going into the loop. The loop portion, this runs forever. So until you power it off or get an interrupt, this code will keep running. So the first line, line 14, what we're doing is that we're writing a high, which is 5 volts, or a 1 to the LED pin. So pin 8 gets 5 volts applied to it. Afterwards, we're printing to the serial monitor that the LED will turn on. And this is a great way to debug and like figure out what's going on with your code. Arduino IDE unfortunately does not have a built-in debugger, so you can't pause your code at certain times and do a memory dump and see like what the heck's going on with all your variables. Unfortunately, that's not a feature available right now. They are coming out with a pro editor, but it's in alpha, so there's a lot of bugs going on. So it's not good for production purposes, but it is available. And so within the next year, I guess, it should be out. But until then, you're kind of stuck with print statements and trying to just print out stuff to their serial monitor to figure out what the code's doing if it's not doing something that you want. Afterwards, we have to put in a delay. Otherwise, it would just turn on and then off right away, and you wouldn't be able to detect it. So the delay is the delay is a built-in function, and it uses the timer that's built into the Arduino. But we don't have to worry about that because the function handles all of the timer backend stuff. All we care about is that delay takes in an input of um, milliseconds. So 1,000 milliseconds is equal to 1 second. So it stays on for 1 second. Afterwards, we're going to do the same thing, except write low to it. So we're going to turn it off and then print that it's turned off and then put in another delay. So it's critical that you put in another delay afterwards because this is a loop, right? So right after you turn it off, it'll turn right on again if you don't have a delay. And so you're just gonna be stuck there wondering why your code's not working when it's just that you forgot to put in a delay. Don't ask how I know. It's a long story. So yeah, Any questions so far? Feel free to stop me anytime if you have any questions. Okay. So now that you have the code written, how do you transfer it to the microprocessor on the Arduino? Because right now it's just stuck on your computer. Well, there's like four steps, right? So you'd go into tools, and then you want to make sure you have the correct board selected. Like I mentioned before, there's a whole family of Arduino products that you can use. So you want to make sure you have the right um, one selected. So we're using right now it's highlighting Arduino Nano, which is this, but we're not using a Nano. We're using an Uno. So we'd go to Arduino slash Genuino Uno and use that. And then the next thing we want to make sure that we do is we select the right port. So the port is whichever USB port that you're using. And sometimes, like let me pull it up right now. So we go here, port. There's multiple ports that are available, and sometimes there's only one, and it just really depends. And sometimes it'll say Arduino, or sometimes it will just say nothing, like what it's saying right now. So you just kind of have to do a trial and error, and eventually you kind of realize which ones are the Arduino ports and which ones are ports for other systems. So just something that you just do by trial and error. After that, you can hit verify, and verify what it does is that it does an error checking of all your code. So let's say you forgot a semicolon, it will catch it here before it even does an upload. And it just makes sure, it's just kind of like sanity check to make sure that your code but in syntax form is actually correct and that you're not messing up on syntax. It doesn't check any of the logic, it just checks the syntax. And then afterwards, you can upload the code. And then uploading, it will transmit it to the Arduino. Okay. Any questions? Okay. So this is the circuit that we'll be building today. It's a fairly simple circuit. So we have this push button right here with a pull down resistor. This is what I was talking about a little bit earlier when we said we don't want it floating. This will pull down the value to ground whenever there is no signal or there's no high. And then when there is a high, it will let it go up to the value so that you can, the Arduino can detect that it's a high. And then afterwards, the Arduino will send a signal to this LED. There is this resistor right here just to limit the current, and then it goes to ground. And then the Arduino is supplying the voltage and the ground right here. So for this, I'll have this on the right side of my screen, and then I will build the circuit in front of you guys right here. And you guys can also follow along and build the circuit with me. If you guys have any questions about your circuit not working, I can try to help debug it on the spot. So I will have that on the right side, and then this is the code. Actually, I'll just have this full screen. Yeah, okay, so let me just take this apart real quick, and then I'll explain what I'm doing as I'm doing it. Okay, so I'm not going to take these apart because these take a little bit of time to put back in. But basically, this is just a tactile button with a big knob on top. It's just like the button that you see right here. When you press it, it makes a click sound. So this button has 4 legs, but so this left half of the legs, so this leg right here and this leg right here, those are connected together. So they're continuous. And then this button leg right here, and then this button leg right here, those are also connected together. Oh, the schematic, yeah, it's fritzing. Fritzing right now, it costs like €8 or something, but you can do some Google searching and find a previous version for free. They just recently switched it to being non-open source. So yeah. Okay, so yeah, that's the left side and the right side. So the left side and right side are only connected from the top to the bottom, but not to each other. When you press the button then that makes a connection between the left side and the right side. So that's kind of the basics behind the button. This is an LED. I don't know if you guys can see that really well, but it has two legs. So one's a longer leg and one's a shorter leg. And the longer leg is where the signal comes in through, and the shorter leg is usually to the ground. So we'll just plug this in right here. There's already a ground connected right here, so I just connected it together. I'm going to assume that you guys know how breadboards work. Does anybody not know how a breadboard works? I will take that as a no. So I assume that everybody knows how a breadboard works. Okay. And then right here on this button side, there is a wire connecting the power rail to the leftmost leg of the button. So those are connected right here, similar to the schematic on the screen. Okay. And then we'll first start in by putting a 220 ohm resistor in series with the LED. So let me just plug that in. Okay. And then we'll take a wire and connect it in series with the resistor. And then we'll plug that into port 7 or pin 7 on the Arduino. And then we'll take another wire. We'll go to the rightmost leg, the top rightmost leg of the button. See right there. We'll connect that, and we'll connect that to pin 13. You want to make sure that you connect it to pin 13 and not the ground above. I've had that trouble before, and it doesn't really do any harm. Your circuit just won't work, but you'll get the Arduino will turn off because you're shorting it to ground. And it doesn't really harm the Arduino because it has some built-in protection, but it's just something to keep in mind. So if your Arduino just turns off when you're building the circuit, that's probably why. Just check your pin 13 if it's on ground or if in actually pin 13. And then we'll connect a resistor. This is the 10K resistor to ground and to the bottom rightmost leg. So this is the pull down resistor. So it pulls down the value to 0 when it's not connected to power. And then we'll plug in ground. And just make sure that's ground, yep. And then we'll plug in power. And so I'm connecting power to the 5 volts header on the Arduino Uno. So that's pretty much your circuit. Do you guys have any questions? So resistors don't have to go in any certain way. Resistors they don't have any certain polarity. The only thing that has polarity in this circuit is your LED. So you want to make sure that your long leg of the LED goes into the side of the resistor. And on the schematic, you can tell which side is the long leg because it has that small kink in it. And if you happen to not plug it in correctly, the LED won't light up, and you can just flip it around and plug it in. Does anybody have any other questions? Anything with their circuit? Okay, feel free to stop me later if you have any problems with your circuit, but I'm just going to move forward and explain the code. So this is the code. I'm just going to explain it. I will send you guys the code so you guys don't have to copy and paste it. So this is a copy and paste. You can copy and paste the code from here. I'll send this link in the chat. Okay, so what this circuit we're going to do is that we're going to make 2 button presses turn on the LED, and then if you press it once, it's going to turn it off. So we're going to have a counter that keeps track of how many times you press the button, and then we'll have it, once it reaches 3, we'll have it turn the LED on, and then once it reaches 1, we'll have it turn off. So after 3, we'll reset it to 0, and then we'll start it over again, and once it reaches 1, we'll have it turn off. Okay. Were you guys able to access the link and copy and paste the code?
Yes.
Okay, for sure. Okay, so I will explain it in Arduino. So Arduino, I guess another thing to know is that if you have double slashes like these, those are comments. So that's not actually being run in the code. These are just to help you, like the user comment about what their code is doing so that other people can read it and understand what's going on. So right here, we're going to declare the button pin as pin 13. That's the one we plugged into for the button. And then the LED pin as pin 7, the one we plugged into the Arduino. And as you can see, these are constant integers. So that means that these are immutable, so they cannot be changed. Oh, schematic. Ooh. I'll have the schematic up on the slide, and then I'll talk about the code. Is that okay? Okay, for sure. Okay, so we start the counter at 1. So we have the counter as an integer because the counter will be continuously changing. It's not a constant integer, which is immutable. Now we have to record the previous or the current button state, right? So is it pressed or not pressed? And that's going to be a 0. We're going to initialize it as a 0. And then we also want to record the previous state if it was pressed or not pressed. And that's going to be initialized as a 0 as well. So now we're getting into the setup part of this, right? So we're going to call pin mode button and declare it as an input. So the button is the input going into the Arduino, and then the LED is the output coming from the Arduino. And then we're also going to start the serial monitor. And like I mentioned before, 9600 is the baud rate. And then I'll show you the different baud rates on the serial monitor when I start it up. Okay, so now going into the loop portion. Like I mentioned before, the loop portion is the one that's running continuously. So until you power it off or there's an interrupt, this will run continuously. So first thing we do is we read the button, the value of the button, and it's a digital read because it's either a 1 or a 0 versus an analog read, which is a value between 0 to 1024 or 1023, sorry. And analog read can be only done on the analog pins, which are right here, but we're only utilizing the digital pins. So it's either going to be a 1 or a 0, so a high or a low. And we're going to put that value to button state. And now we're doing some basic if statements. So the if statements, if you aren't familiar with programming, they kind of read like normal English. So if the button state is not true or is not equal to the previous button state, so this right here, this is an inequality for not true or not equal to. So we're comparing our current button state to our previous button state. And in the first iteration of this, we know that the previous button state is off. And we check if the current button state is off, basically. And if it's on, we're going to jump right into this loop. And then we go back into another loop, or another if statement right here. If the button state is equal to a 1, so if it's high, we're going to increment the counter, which we declared above, by 1. So this statement right here, the plus plus, is a shorthand notation for counter equals counter plus 1. So you're taking the current value and you're adding 1 to it. Afterwards, we're going to print the value of counter to the serial monitor so we can keep track of how many times we pressed it. And then we're going to have a delay of 50 milliseconds. So we have this milliseconds delay right here because this button is a physical piece of hardware. Physical pieces of hardware, they aren't like very clean. When you zoom in all the way in their time spectrum, time data, when you press it, it doesn't just go from off to on. It's gonna bounce a little bit from off to on to off to on, right? And we don't want to read all of that bouncing. We only want to know if it's a 0 and if it's a 1. We don't really care when it switches back and forth in that small time span. So we're using this delay to stop us from reading right away so that we get rid of some of that noise right there. There's a lot cleaner ways to do it, but this is one of the simplest ways. And this works for a majority of the cases. And then now we're going to declare our previous button state as our current button state. So we're just refilling the value. And then now this is the part where we turn on the LED or turn off the LED. So this is another if statement. And if the counter is greater than or equal to 3, we're going to, what is the purple wire going from the on Arduino? Okay, so the purple wire goes from pin 7, which is on this side. It's this wire basically, and it goes from pin 7 to the 220 ohm resistor that's in series with the LED. Does that answer your question? Pin 7 is not the PWM, at least not on my board. Pin 6 is PWM, but we're not really utilizing PWM, so it doesn't really matter. You can, honestly, you can go plug it into any pins that you want. I just, you would have to change the values that they're declared with up here. So if you were to plug it into a different pin, just make sure that you change the values that they're connected up here. When the button is pressed, does it connect all the 4 pins? So this button, the bottom and top of the left side are connected by default. So it's basically one piece of, you can think of it as one piece of wire that connects from the bottom to the top side of the left side. And then on the other side, the bottom leg and the top leg are connected. So the right bottom leg and top leg are connected, and the left bottom leg and top leg are connected. And then when you press the middle part down, it makes a connection from the top and bottom of the left side to the top and bottom of the right side. So yeah, all 4 pins are connected, if that makes sense. Does that answer your question, Brian? Okay, for sure. Okay, so back to the code. So this is an if statement, and basically it's reading if the counter is greater than or equal to 3, we're gonna write the LED pin as high. And like I mentioned, high would be equivalent to a 1 or a 0, which is basically equivalent to 5 volts or like 0 volts, like nominally, those values. And then after it reaches 3, we're going to reset the counter to 0. And then we jump into an else if statement. So else if the counter equals equal is an inequality versus just one equal sign where you're assigning that value. So just something to keep in mind. This is consistent across all programming languages. So counter, if it equals 1, then we're going to turn the LED off. So basically digital write LED low. And this is an implied else statement. So else, it basically does nothing. So so basically if the counter was 2, it would not do anything because there's no value or any action associated with that. And this is called an implied else because we don't really need to address it. It's just does nothing. Okay, any questions about this code? Okay, So I will take that as a note and I will program this now. The code's already running on here, but I will reprogram it. Okay, so when you plug it in on a Windows computer, you're gonna hear like the USB connected noise, and then you can see that the green LED turns on the Arduino. And because I already have the code uploaded, the code stays in its memory. So then you can see the LED turns on, um, and then if I press it one more time, it turns off. So 2 presses, turns on, and then it turns off. So now I will go in and program it again with the same exact code, just so you guys are familiar with how to do it. So first thing, we go into Tools right here. We're going to go check the board, make sure it's Arduino Uno. Arduino Uno right here. As you can see, there's a wide variety of boards that you can use. And then there's all the other boards too. This is for the ESP32, which is this module right here. You can also program this using Arduino IDE, although it's a little bit more steps, but it's pretty straightforward too. And there's a lot of documentation on this. As you can see, my COM port is COM5. And as I mentioned before, it already knows that it's an Arduino Uno that's connected to it. Sometimes it works like that. Sometimes it won't show up. It'll just be COM1, COM5, and whatever other COM ports you have. You just kind of have to go trial and error and see which one works. If you were to select the wrong COM port, at the bottom of your screen in this black and teal colored area, you'll get an error, and you basically just, it'll say fail to upload, and you'll just go back and change your COM port. So it's pretty straightforward. Let's say for some reason you didn't know what board this was, you can hit get board info, and it'll tell you the Arduino, what it is. So it's an Arduino Uno and some like serial numbers and stuff. I don't really know. I've never had to use like VID, PID, or SN. I actually don't really use this function that much because I always know like it's an Uno or a Nano or whatever. Seems like my Arduino has frozen. Sorry, give me a second. Sorry, my Arduino IDE froze. Okay, let me just open it up. So when you first open up Arduino, it has the loading screen, and then it loads the most recent save. So there's this. Okay, so let's go back. Let me plug this in. Okay, and then just make sure board, Arduino port. Then we can go into verify. See at the bottom, once it's done verifying, it'll say done compiling, and it'll give you some data about how much memory it's used. I've never had an experience where I've used all the memory, but maybe if you're doing some big programs, you might encounter something like that. And then we can hit upload, and it'll say uploading, and on the screen, I don't know if you saw it, but the Arduino lights flash right here, the TX and RX lights, and that shows that it's uploading. And then now you can see that it says done uploading, so the code's stored here. So now if I press it twice, it turns on. If I press it one more time, it turns off. And then I'll show you guys the serial monitor. So if you go to the top right, there's this what is it called, magnifying glass thing, and that's the serial monitor, and it pops up with this right here. You can change the baud rate, so we're using 9600, so you want to make sure it's 9600, but as you can see, there's a wide variety of baud rates. So 19200. This is another common one, 115,200. Okay, so Eileen, for your board, you're using a Mega. If it has an A in front of it on the pin, so you're saying you're using pin 7. This is a Mega. It would be digital. So you just put 7. It wouldn't really matter. Okay, hopefully that answers your question. Let me know if you have any trouble hooking that up still. Okay, so back to this. So 9600, that's our baud rate. And then we have all these. So if you wanted to, you could also write commands to your Arduino and it'd send it over serial, and then you can use code here to decipher those commands to output something. So let's say you had an LED screen, you can type code to output and display onto your LED screen. Or let's say you had, so the difference between the baud rates is just the rate of transmission, I guess. And different sensors are by default on different baud rates. So you just need to make sure that you're communicating on the same like rate, basically. I don't know the very specifics of why they're at different frequency or different rates, but I just know that if you want to communicate with a sensor or anything, they should be all at the same baud rate. And for our purposes, Eileen, we're using 5 volts. So these are connected to 5 volts. I'm not super sure about the higher the baud rate, the faster it is. I assume so, but don't quote me on that. I would need to do some more research on that. I've never used serial.n. I think serial.n would close the communication channel. How you would change the baud rate in the code is basically right here where it says 9600. We can just change it to a different value. So let's say, let's do 115,200. So let's do this, 115,200. And we'll verify. And we'll upload. Okay, so we updated the baud rate to 115,200. Now we'll just close the serial monitor. We'll open up a new serial monitor, bring it to this screen. Well, we have to change the baud rate to 115,200. And then once you press this, it shows up as 2, 3, 1, 0. So it's basically however many times I pressed the button, right? So 2, so the next time I press it, the LEDs should turn on, and it turns on. And then next time I press it, it's going to be 1 for the counter, and it should turn off, and it turned off. So this is a good way to help debug your code and figure out like if it's going to the right places, if there's something going on that shouldn't be going on, or if you missed something. This is like one of the best ways to help debug your code. I can also show you what it would look like if we were to use a baud rate that didn't match. So we're on 9600 while our baud rate on the code has been updated to 115,200. So now let's see if we try to send something. As you can see, it just sends question marks because we're communicating at 2 different rates, and so these aren't in sync with each other, so it doesn't really know what it's getting. But the moment we change it back to the correct rate, it gives you the right value. So that's it for the serial monitor. Like I mentioned before, you can also type in commands here and have your code read from the serial and output that to an LED or do some other things. You can get really creative with it. I've used serial to read from a program on my laptop running Java. So I had a Java program running this. So I guess I should start from the beginning. So I had an Arduino connected to a big switch, which was a piano key. And when you pressed on the key with your feet, it would send a high signal to the Arduino, and the Arduino would output that to the serial like this. But instead of numbers, it'd be letters. And then I would have a program on my laptop running Java, which would read from the serial and it would play a sound. So it would play the musical note associated with that key. So it was a giant piano, but with like Arduino and Java and your laptop. So it's pretty cool. So there's a wide variety of things you can do with this. You can communicate with like Bluetooth, and you can have Bluetooth communications. You can use, this one has Bluetooth built in and Wi-Fi built in, but Arduinos you can get I think it's called a shield or like a sensor that you just plug in with the different pins and use that to control something via Bluetooth. So there's a wide variety of sensors available, and you can basically pretty much do anything you imagine with an Arduino. It's very versatile. Sometimes you're going to run into some limitations on like the computing power, but then you can always go up to like other microprocessors, so the ESP32, which is a lot stronger, and then you can also go up to like a Raspberry Pi. What is the orange cable connected to? So the orange cable is connected to pin 13, which connects to the switch. And that's pretty much it for this presentation. Do you guys need help with any of your circuits, or if you have any questions, feel free to ask right now. But that's pretty much the introduction to Arduino and the basics. There's a lot of things you can do with it. Analog in pin. Pin 13 is digital, so I don't know what you would want to connect it to on your Mega. So I hope if you guys followed along, that your circuits turned out okay. And if you have any problems, feel free to just message the chat or unmute yourself and talk right now about any problems that you encounter, and I can try to help debug it right now. And if you guys haven't already, please join our Discord. We have announcements and workshops like these posted. This workshop recording will be posted maybe like tomorrow or later in this week if I remember. But all of our workshops are posted in our workshop directory channel in our Discord. There's an Excel sheet with all of our previous workshops, all the recordings and all the material, like the slides provided, so you can always go back and reference them at any time. I will also embed the link to the code, the pasted code, so you can always just copy and paste the code instead of having to look at the screen and transfer the code. And if you have any questions, always feel free to go in the general section and their questions channel and at me about Arduino questions or just anything about IEEE. I'm more than welcome to help, and our officers also more than happy to help. And yeah, that's pretty much it. Thank you guys for attending. I hope you guys learned a lot about Arduino. And yeah.